Scala programmer for almost 10 years now. It's been an amazing journey.
Just wanted to start by thanking everyone for giving up their Monday evening to join us here. I think we can all agree it's a fantastic space to be in. For those of you who don't know me, my name's Charlie. I'm from UMatter and Scala Matters. Just want to give you a very quick rundown on kind of us as a community, talk a little bit about the event that we've got this evening, point out some important faces as well around the room. So very quickly on UMatter, we are a functional programming specialist recruitment firm. Been doing it for 3 years now, kind of our bread and butter, over 50 years of experience in the company. And within that, we really felt that we wanted to give back to the community. And that's where Scala Matters came from. So we do events all over the world, meetups with people like you guys who really make it, and working with fantastic partners like Sirius. And a little bit on Sirius. So we've got Raoul over here and Miriam as well. If you guys want to have any conversations about kind of careers, talking about Sirius, be great for you guys to have a chat with those guys afterwards. We've got some pizzas coming at 7 o'clock. So once we get through the talks, we can have a little bit of time for networking. 2 fantastic talks coming up, one from Ben and Luca at Sirius, and another one from Reed over at Improving. And yeah, thank you very much for being here. I'll hand you over to Ben now, and we'll go from there. Cheers.
Thanks everyone. Thanks everyone for coming out. It's exciting. I think we were internally chatting with our team, and we didn't know the last time that there was an actual Scala meetup in New York City. So really appreciate you all coming out. It's as you can see, and I'll talk a little bit about what we're doing here at SiriusXM, but Scala is a main reason that we have been successful here. So yeah, definitely excited to give back to the community any way that we can. And so yeah, excited to kick this off. So quick introduction about myself. My name's Ben Manning. I lead platform services for SiriusXM. We have an organization of around 300, mainly engineers. We also have project management as well. And we do run on the JVM, so both Scala and Java, the majority being Scala, which we can talk about more as we go. And I want to say that we probably have right around 200 Scala engineers. So we have a lot of Scala engineers. Everything from folks in the open source community that work for us, all the way through to just folks that are writing backend services. So we did just release relatively recently our first open source project. And so, yeah, we're going to try to work on continuing to contribute. So I'll let Luca introduce himself, and then we'll kick off the presentation.
Yeah, hi guys, I'm Luca. I've been working at SiriusXM for about a year now, a little bit more. I've been a Scala programmer for almost 10 years now. It's been an amazing journey, and SiriusXM is, yeah, probably the biggest company I've ever worked for, and definitely the most Scala engineers I've ever worked with. So yeah, it's been very cool.
And as we go, this is a small group, so cut me off, cut Luca off. If you have any questions, yeah, just jump right in, because yeah, this is a small group, so I want to keep this as informal and interactive as we can. So real quick, who is SiriusXM? SiriusXM is an audio ads company. We have many companies within SiriusXM, and some people don't realize that. So we have Pandora, Ads with Simplecast. So everything from podcast ads platform, from podcasting to an ads platform, to Pandora, to SiriusXM, which is our staple product. So talk a little bit SiriusXM at a glance. What size are we talking about? We're talking about 33 million subscribers, 150 million listeners, 9 billion in revenue, all supported by around 1,200 engineers. So big, building services at scale. And so I've been with SiriusXM for about the last 2.5 years now, and we underwent a digital transformation where we built a new platform and mainly in Scala, and we can talk about that, that we built and launched at the end of last year. So it was a massive undertaking where we had to build, including migrating those 33 million subscribers, which Luca felt the pain of more than most. And so, yeah, we got to build a new platform from scratch, following some of the design principles that we can discuss, as well as dealing with the big migration, and we launched that at the end of last year. Now that we have that launched, we're continuing to innovate on that. And so what? So I kind of talked about that, building a modern platform. Why? If you look at it, like if you look at the why of the company to shape the future of audio, where everyone effortlessly is connected, voices, stories, and music they love, we were dealing with a big legacy tech stack that had been built over 15 years, that had reliability, resiliency issues, and massive effort for change. And so our goals were to, again, like our goals were not to write Scala. Like our goals were to improve the user experience, optimize for speed and innovation, enhance our organizational agility. Scala is a tool that allowed us to meet all of these goals, and we did. We built it AWS cloud native, multi-tenant platform with maximal uptime. Looking at the architectural design from the beginning, really, how do we build highly aligned, loosely coupled services, allowing each of our independent teams to deliver business value rapidly? How do we go about that between the domain-driven design, the correct, clearly bounded context, our event-driven architecture, and then a big one here, which is our Scala 3 and API collaboration. And Luca will get into that in his slide. And this just gives you a quick snapshot of how I think about it between our AWS infrastructure, how we have each of our services, right, and how those are within there, and then how that API registry and our dev tooling supports all of this. Why contract first and why Scala 3, right? And I don't think I need to explain this. Like you guys can read this, and I'm sure you're all here because of this. But the big, I would say, paradigm shift, or the big thing that we leaned into, is really this contract first approach, which is API registry and Smithy, right? And it's auto generating our HTTP routes, clients, and domain models. And so where this was massive value, not just to each of the individual teams, which Luca can talk to that at length, where this is massive value is how did we build a platform at scale with 200 Scala engineers and 300 individuals, and that's just our organization. On top of that, we have a full data organization, and Evan can speak to the need for the contracts as well as what he needs from his data side. We also have our client engineering counterparts, right? So client engineering, they need to understand our APIs. The data org needs to understand our events. How can we build software in parallel in a very tight timeline across many distributed teams? And this was the underpinning that allowed that to be successful. And it honestly made our lives so much easier, especially given the time crunch. And so this is just kind of closing. And one of the things I would say, the first 3 weeks post-launch of this new platform, so we're talking about legacy tech debt, we're talking about services, different design pattern, moving this to, again, mainly Scala 3, 3 weeks post-launch, we shipped more updates and code, bug fixes, features in 3 weeks than we did the entire previous year. And that was just due to challenging rollouts and deployments and a different service architecture. Whereas having the correct foundational model allows you to really get code out there quick. And Luca's probably got stories of how quickly he's had to get changes out and fixes out there. So yeah, that's me. Happy to answer any questions. That's just super high level. And then really what we wanted to dig into with Luca from the actual engineering side is this Smithy 4S at SiriusXM and how we think about the contract first development. But before we kick off to Luca, definitely want to open up for any questions for myself, and we can also deal with questions at the end.
What were you coming from? What was it like before you...
Great question. So we had everything from Clojure to Go to Java. We did have some Scala as well. We were running on on-prem, GCP, AWS. So if you look at where we came from, we also had C++, monolithic, on-prem. So it was we had everything. And that was the challenge, right? So if you were an engineer and you wanted to go switch into a new context in a new domain, it was switching languages. It was, you might as well have switched a different company. And one of the things that we set out early on, like rallying behind Scala and functional programming, yes, all of the benefits that you all know intuitively. But me as the leader of this, one of my underlying goals was I wanted to be able to have a platform service that if I get if I get pinched up for resources because we got a big initiative, we can take a team that can move over and surge, and we've done this successfully. And this, to me, we had an example where I'm not sure if it's public yet. I'm not going to say the specific example because it might not be public yet, but there was this big initiative that we had that there was a specific team that was a pinch point and a bottleneck. And to me, the example of this succeeding was I was able to take another team that didn't have the context, didn't have the domain knowledge, but immediately move them over, and they were able to build in the same design and patterns that we followed and be successful.
Did you have to train everybody on Scala?
We did not have to train everyone on Scala. We actually hired a lot, like Luca. So the majority of the folks that we have now are new. We do have, for the Scala functional programming folks, the majority we have are new. We do have some folks that had Scala experience already here, but the majority of the actual Scala functional programming folks are new within the last 2 years.
What was what phase of the adoption, I guess? Like how many, I guess, were these actually independent things to start, or were they always under the?
It's SiriusXM's had an evolution of where it's at. So Sirius was itself, and then there was XM, and they were competitors like 15 years ago. And then they were both in a almost in bankruptcy, and then there was a merger, and then it was SiriusXM, and then SiriusXM then acquired AdsWiz, and then acquired Pandora, and so it's kind of gone through that evolution. And that is an evolving thing, and that is one of the reasons we built a new platform, right? Is on top of just the languages that I said that we had, like now you also have multiple fractures of different products that had never been consolidated. And so this is where needing a multi-tenant platform that can be the platform that then supports all of that, right? So this is, and where we're at in that journey is launching the platform for SiriusXM, but where we also have to go for that is starting to pull in a lot more from some of those outside things that you mentioned.
So what's like the adoption platform?
So right now, just SiriusXM, which is what we launched at the end of last year. Yeah.
How long did that take the process? The adaptation?
I've been here for 2.5 years. We did not start when I first started, like, cause like, again, we were working through strategy. Like we didn't even know if we needed to build new in a new platform. When it actually came to like product, having input into building new design and stuff, like it was under a year. However, there was things that we started earlier than that, right? Like the AWS infrastructure side that we started. Some of the like actual platform engineering designs was earlier, but the bulk of the actual services that we built was all under a year, inclusive of there were areas that we had challenges that had less of a time. And Sindhu's here from the playback team, and she leads the playback team for us. And she had under 6 months. So she's a great example of having a team that is behind just, and it was not because of her team's fault. It was actually the team didn't even get started. And then when the team finally got formed, they had under 6 months to build all brand new services for playback and to get it launched, and it went really well. And so I think that shows what it having the correct pattern will empower, right? Like you can move quickly as needed. Not saying that it wasn't a ton of work, but yeah.
Can you tell us something about how did you get the go-ahead to make such a massive change?
That's a great question. So the point of this was not necessarily rebuild a new platform just so that it's in AWS and it is Scala, right? Like at the end of the day, there has to be business value. So the business value here isn't Scala and AWS. The business value is we have 15 years of tech debt. We have forced maintenance windows where we have to shut down our commerce systems and we can't actually take people's money. We don't have 100% uptime and reliability, right? So the actual incentives was we need to improve the user experience. We need to improve our performance and reliability, right? And we need to, and this was the biggest reasoning, is the technology was limiting the business decisions where it really needs to be the inverse, right? The business would come with an idea. They would say, hey, I get this. I see this is what's happening in the market. I need you guys to go execute on this new initiative. And it would take an absorbent amount of time, effort, and resources. And even then, we were then holding back of what was even possible. And so this is really investing in towards a foundation where you flip that on the inverse, which is we now can empower the business to be able to pivot and make decisions quickly. So that's really why we were able to then use Scala, right? All of those reasons. And then, okay, well, we need to build services at scale. Scala is a great fit for that. It can't just be, or at least it couldn't be for us, as just to build, right? It's got to have the business value and outcomes.
What's it like using Scala on AWS?
We love it. I mean, we have a pretty robust ecosystem, and maybe what we'll do is we'll pause there because I know Luca's going to go into some of the actual underpinnings, and so we'll talk about Smithy 4S. We can definitely dive back into the AWS side of it, but yeah, let's do that so Luca has time. But that's a great question.
Yeah, hello again. Just grab this. I think my first slide here is just introducing me again. I already did that. I'm a staff engineer at SiriusXM. I maintain a lot of type-level libraries, including things like cats effect. And I am very enthusiastic about functional programming, which is why I'm here at SiriusXM in the first place and here today talking to all of you. So yeah, what I want to talk about today is Smithy, and by extension, Smithy 4S and contract first development. So how many of you have heard of Smithy or know a little bit about it? Okay, cool. Excellent. This is great. I can tell a lot of you about the cool things that Smithy enables. Is it? Can you guys hear me all right? I feel like there's a lot of, okay, cool. Yeah, so what Smithy is a declarative language for defining services and SDKs and entire systems. And think of language not as like a programming language like Scala, but more something like XML, JSON, or the like, where you're really like defining a data structure as a language. This was built by AWS, and it's only, I think, recently been published in the last 5 years, but they've actually been building it for like over a decade, and they basically use it to power all of their systems in AWS. So what it really is it allows you to define whole services with all of their endpoints, their operations, their resources, and have a data structure representing it. And once you have that, you can then generate a bunch of different code that basically represents how you want to interact with these services. So, for example, you could have code generation for server like framework, or you could generate clients that basically look at the data structure and say, oh, okay, these are all the endpoints. Now I'm going to create just like a Scala class, for example, that as its members has all of the endpoints. So let's look at a quick example. I hope you can all see this. But basically, we have a very, very simple endpoint called operations in Smithy. This one's called hello. And it's basically just a very simple hello world application where it takes a person as an input and it outputs a greeting. We have this little annotation at HTTP, which gives us the method. It's a post, the URI, which is /name, and then the HTTP status code, which in this case is 200. And then further down, you can see the person structure. It has two annotations here, HTTP label, which basically means it's a label inside the URI, as you can see, right? The name. And then the @required basically means that it's required. It's not optional. And then the greeting just includes a message as a string. And the cool thing about this is all checked at compile time. So when you basically compile the Smithy code, and it will say, oh, okay, well, for example, if instead of name you named it something else like hello, this thing would not compile because it could see, okay, well, you have this name in the URI, but it doesn't match anything. So you get a little bit of compile safety upfront. You can apply lint, but basically the output of all of this is just a very defined data structure that you can introspect and analyze. And so then there are different interpreters that you can use to generate code from this data structure. So Smithy 4S is one of these, and there are many more. But for example, if you wanted to create a client, an HTTP client for this specific Hello World service that right now only has a simple hello endpoint, you could do it like this. So this is some boilerplate, but basically you give it a client. In this case, it's a simple HTTP4S client. You give it like a base URI, and then it gives you an object that you can call all of its endpoints on. So in this case, you call hello, you pass a person, in this case named Luca, and then what you would get in our case here is an IO of greeting, which, if you go back, basically is just an object with a message as a string. So very simple, but I think it can already kind of show you some of the power that Smithy 4S enables. I've talked a little bit about code generations, but one of the big advantages of using something like Smithy is that it's protocol agnostic. And that means you can generate code for a number of different server and client languages. So you write your service once in Smithy, you get the Smithy model, and then you can generate clients for Scala, for Java, for TypeScript, for Kotlin, Swift. There's I think 8 or 9 supported code-gen interpreters for it. And then there's, I think, at least a handful of server languages. So in our case, we use it to interpret into HTTP4S. So you write your Smithy spec, and at the end, then you implement this spec using the generated code, and that gives you the server for free, basically. Furthermore, you can support a lot of different serialization formats. So what we saw in the previous example was HTTP, very standard. But the annotation, the @HTTP annotation, isn't some built-in Smithy thing. It's basically just a construct that the Smithy developers have defined for you. So if you wanted to, you could define your own annotations, and that we have done that internally at SiriusXM for different things like events and such, or even if you wanted to go gRPC, protobuf, all of these things, right? So it's not bound to any specific protocol like JSON or anything. You could switch to a binary language, a binary protocol. it's very powerful because in the end it's just a data structure that you can use to your heart's content. And I think one of the great things in terms of compatibility is you can generate open API specs, and from there, you basically have this ecosystem of all these other things that integrate with Open API. Yeah, and one thing that we at SiriusXM really do is, define asynchronous APIs using things like Kinesis streams. And so we define all of our events using Smithy. And then in the code, we basically have all our models pre-generated. And then we can just put them into these streams. And we get the consumers and producers for free. So contract first development, what does it mean? Basically, what we do is before we start writing any code, we sit together and we try to agree on a Smithy spec upfront. So if you have maybe a client and a server team or two server teams, some kind of agreement needs to happen in order for these two teams to work together, right? So maybe it's a service to service call or it's a client to service call. It doesn't really matter. But what we want is to really facilitate communication upfront. And when, maybe you need to introduce a new endpoint, and you can agree on all the fields, and you can agree on the optionality or the requiredness of these fields, the data types. And it really doesn't leave any room for ambiguities, right? Because you've agreed on it up front, and there's code to show. And what this really allows is clients can really start integrating immediately, right? So you have this definition, then you can generate the client. The server team goes and works on the server part. The client team works on the client part. They can work in tandem. There's no waiting we need to wait for this endpoint to start existing for us to integrate with it. Smithy for us actually gives you really nice, simple way to kind of give you mock data. So you can, once you have the Smithy spec, you can basically run a server that just gives you example data very easily. So as a client, it's very, very nice. And as a server, it means you have decoupled all of your business logic from the actual server. So that's really nice. And furthermore, a lot of these contracts that we have are Scala to Scala, but a lot of them are also Scala to front end, specifically TypeScript at SiriusXM. And at a previous job, we used something like Topier Endpoints for S, which has a very similar idea where you define endpoints or services as data structures, but they're all written in Scala. In this case, they're all written in a very, very simple language that any programmer can learn in, I would say, a couple hours, really. Obviously, there's intricacies in a little bit, but for the most part, it's very, very simple and straightforward. And so you don't need to speak the same language because you can all agree on this is the data structure that this endpoint expects. And furthermore, sorry, go ahead, question.
Are you using abstraction using something like GraphQL?
So we don't use GraphQL. There is a lot of different abstractions we use. We don't mandate them across teams. Most of our data stores are DynamoDB. So there are different abstractions we use, but a lot of it we wouldn't. You wouldn't use the models that the Smithy spec generates and plop it straight into the database. But you could if you wanted to. I wouldn't say, but yeah, okay, cool. Yeah, question.
You mentioned that it was possible to cogent to different target languages.
Mm-hmm.
Are you definitely using that in production now? Non-solid target software.
I mean, I'm 99% sure that we're doing that for TypeScript. Yeah. But yeah. I'm not in charge of the client applications, but I think I'm not sure of the history of that team. I've only been here for a year, but I think they've probably built a lot of their stuff in React TypeScript for a long time. So I think, yeah, that would be another big change that would, need to be warranted with business value, which I think it might be a little bit more difficult on the client side than the backend side, but I don't know. Never counted out. I loved Scala.js, but yeah.
Yeah, with what he said, the client engineering, their philosophy is building in the best language for that client application. So for iPhones and iOS, right, like that's Swift. For Android, that's Kotlin. For the web, like React, right, TypeScript. So they're very, and we have other client applications. So like for automotive, for example, where we have embedded systems. It's right now it's mainly C++, but now like what's that next thing? Okay, Rust, right? So it's really looking at the language that's optimized for the hardware that it's running on, less around because the other approach to this is, all right, how do I have this thing run everywhere? So our client engineering side, which again is not part of our group, but they take the philosophy of optimize the language for the hardware that it's going to be running on.
Quick question, Dinesh.
I don't think there are any plans to use Zio. We basically use like type level stack, so mostly Cat's effect, really. Yeah. Okay, cool. I'll continue. So yeah, the last point I'll mention here for contract first development is that there is a single point of truth. You don't need to like remember to update the documentation. You don't need to like look into like, oh, what's the code doing at this branch in particular. You can just look at the actual Smithy definition and we'll tell you exactly what's happening. Yeah. It can get a little complicated, right? Because versioning is a hard problem to solve, and there are a lot of different ways to solve it or to attempt to solve it. But I have a slide. I'll talk about it a little bit, but yeah, basically, yeah. So quick note about documentation. I think we're running probably over time, but Smithy for as code gen gives you really nice Scala that looks really nice. And if you can have any metadata in the Smithy, it is automatically included in the Scala docs. So once you write your Smithy, you generate the Scala code using the SPT plugin, which is very seamless. You have this service basically, integrated into your IDE, and you can like explore the APIs very easily using like type ahead, type complete. And it's a very nice experience personally. And obviously you can generate Swagger docs from the open API, and right for this Hello World service, you have something like this. And yeah, it makes it very, very easy to figure out what other teams' APIs are, what they look like, and what the schema is. And yeah, it's very nice. And so on compatibility, basically at SiriusXM, we've written the API registry to basically detect any breaking changes, right? So you submit a pull request to our API registry, changing like some of the Smithy files, adding Smithy files, whatever, and it will say, oh, this actually breaks. So, and then it leaves it up to you to determine what to do next, right? So, for example, sometimes it can give you, oh, well, if you update all the clients first and then update the server, you're totally good. We can go ahead. But other times, if you add a non-optional field, that's not going to work. And so it will tell you exactly what you can and can't do. But Smithy itself also has versioning in the sense that if you have an operation, an endpoint, you can give it a different version, and it will automatically, it puts like a little prefix in it, like V1, V2. So yeah, it's about like, oh, how often do you want to like churn your APIs versus adding things like optional fields and stuff. But generally, it definitely helps you tell you exactly when something breaks. And furthermore, you can in Smithy you can define dependencies on other APIs. So if you're a service, you depend on all these other services. You can encode that into Smithy itself. And so when you update something, you can like basically traverse the dependency graph and see exactly, oh, this is a consumer. We need to warn them. We need to tell them to deploy in tandem or whatever. Yes, go ahead. So Smithy for us, or Smithy is basically all local. So we actually run, it's all code generated for HTTP4S. So it's an HTTP4S server that runs in ECS. Yeah, exactly. Like we use a lot of lambdas. Yeah. So the registry is basically where we hold the entirety of all the Smithy files for the platform services. It's just a repo. Yeah, exactly. And then you have like a big site that holds all the Swagger and everything. Yeah. Yeah, we have like standard blue green. There's like I think some teams that do like canary deployments. Yeah, we give a lot of the teams like a lot of autonomy on exactly how they want to do things. But yeah, sorry. That's also I think up to the team. But in general, we whenever there's a breaking change, we need to make sure that others are. Mhm. Yeah. So exactly. So if if you opt in an endpoint and that breaks the previous contract, you need to obviously talk to the person that the contract is with or the team that the contract is with, and then decide on what to do in lockstep. If that makes sense. Yeah. Yeah. A lot of times that's what we do, right? We deprecate the old version, leave it in, and then eventually remove it. But yeah.
To like what Luke is saying is Smithy's not solving those problems. Like what Smithy's solving is from the tooling side of flagging that there is a breaking change. Who is it going to break? Now, the mechanism for how you handle the deployments and how you handle the infrastructure, it's completely decoupled from the Smithy side, right?
Exactly. Yeah. Good point. Sorry, go ahead. So the code doesn't get generated in the repo itself. So basically, the way Smithy for S works is it's an SVT plugin, right? And so the code actually gets compiled whenever you pull in the Smithy files as a dependency. That makes sense. Yeah. It does get pretty large, but I think you can compile because the Smithy compiler is very, very simple. You can compile the entirety, I think, in less than 30 seconds or something. Yeah. Don't quote me on that, but something like that. Depends on your computer speed. Yeah. Cool. Okay, I'm going to move on. So I really only have a couple things left. So other things that we've built at SiriusXM are distributed tracing support, right? So basically we support notches out of the box whenever you generate your code. All of the routes and the endpoints are traced through. The same with request context propagation. If you have some kind of request context, it will automatically pass it along to all of your service dependencies. Typed error handling, right? So you can define specific errors for specific status codes for your endpoints. And so if you want to make sure that you're handling all of those, basically you can have an interpreter that gets like an either, right? And so you can pattern match on all the errors and choose how to handle or how to not handle them. You can get API segregation to public and private APIs by like simply tagging them. You can get tagging of PPI data so that, for example, once you ingest them into the data lake, that they get removed or anonymized. And last thing is API key middleware. So for our private APIs, we want to use API keys so that not everyone can access them. And for all of our like service to service communication, we kind of have this like just built in. And yeah, there's a lot more there that we could build that Smithy enables, but yeah, there's a lot of opportunity, and yeah, I think that's pretty much it. Thank you so much for listening, and yeah.
Why do you have the distributor case and not use some
Cool. We got time for some Q&A, so feel free to keep firing questions away.
not use some library?
Yeah, I mean, Natchez, right, is a Scala library that basically integrates with whatever tracing you want. We basically just use Datadog. Sorry, Natchez? How do you spell it? Yeah, Natchez. But it's basically just a Scala code thing that integrates with a bunch of different tracing libraries like OpenTelemetry, Datadog, I believe Jaeger. I don't know. Yeah. Mark.
So it sounds like the Smithy Forest stuff is for predominantly staff. Based on your previous experience, can you talk about what it's like to introduce this ecosystem to stuff that's already many microservices?
So for that one, I think it's more generally the approach that we took was not how do we take what is currently existing and then how do we then try to change it. And so this is more of like, and I'll answer it from a layer up, and then if you want to get specific, is when I stepped into SiriusXM 2.5 years ago, looking at the current design and architecture and what they had here, it was a lot of services built on services built on services, right? And with cascading synchronous call chain paths and trying to fix the problems by adding a new layer on top, right? Whether it's GraphQL, which was added, and then an REST thing that's now added on top of Graph, that now the Graph is talking to all of these services. So the approach that we took in building a new platform was we need to actually fix the primitives, right? We need to completely fix it. So we didn't have that issue because the way we tackled it was keeping everything that was in flight the way it is and not solving that. And there numerous reasons to that. One of that being that. The other reason being is like the attempt before we got here to fix this problem was also, here's a monolith. All right, now let's put this monolith into the cloud, and we're going to then break this into microservices. But in my opinion, you almost get the worst of all worlds, which is you end up with a decentralized monolith, right? I would honestly prefer a monolith over a decentralized monolith with cascading changes and issues and stuff. So we actually didn't solve that because we built from the ground up this new platform that we then launched. That was the hardest part, and Lucas bared the pain of this more than most people within the organization. And from a high level design principle, what it was is, all right, how do we run two tech stacks in parallel? So if the guiding principle being, we're building a new platform, we're going to build new front end clients, like a new iOS, a new web, a new Android app. How do we allow the old apps to work? And how do we how are we going to upgrade and how are we going to roll this out? The guiding principle being it's going to be the client app being updated that moves them into being able to operate off the new platform. So the example being is on my iOS phone, right? I have the old app, I'm using it. I then get a new update to that. I click update. That update then pushes me into the new. Now, how do you do that? It's with a whole data migration sync feed that Luca has had to struggle with for a while.
Very briefly, it's basically we have a lot of old Postgres systems, and we use change data capture to put all of that through DMS into a Kinesis stream, and then that Kinesis stream goes into a Lambda, and then the Lambda talks to the new services, and yeah.
So if you think about it that way, we can run both in parallel and you can just be off the old. Because why did we have to do that pattern is because we have old devices that will never be updated and you can't just shut off and you can't just kill, right? We also didn't want to do this, try to finagle a big bang, which is like, all right, now I'm taking massive risk. We still took massive risk and went really, really fast, but really wanting it to be on the individual client app moving over.
For the Smithy cases where you have like the synchronous HTTP and then you also have a Kinesis, is that also chip capture or is that handled by the app team that's doing it?
Yeah, so the Smithy doesn't really give you anything in terms of like actual implementation, right? So basically what we do is we define our services, then we use change data capture from Dynamo, which basically gives you just the raw data coming into Dynamo, right, when you write to it. And then we use a Lambda to transform that into domain events that are actually, the actual ones defined in Smithy.
They match the
Yeah.
same contract.
They don't match the same contract as the synchronous API. They could, but usually we have two different things. Yeah.
Yeah, we have the API definitions, which is the HTTP that the front end clients think about, as well as what our private APIs are. So the example being is we have customer service, right? Like we have internal operations teams that are hitting our private APIs, but then we also have our public APIs for the front end clients. And then for each of those, we also then for the data organization, right? Now we have the event side and the CDC side, and we work very closely with the data org and Evan's here, and he can answer any questions from the data side on how we could have using Smithy have the same definition so that he could just build one ingester that we're following the same pattern on, and now it doesn't matter how many different services we have, that ingester is going to work with being able to ingest all.
I have a question, I think that's aimed at Smithy, but also your implementation. I'm wondering if Smithy permits you to do sort of program by contract at the value level as well. In other words, can you put constraints on the values received? A lot like, Berkshire Meyer and Eiffel and all that.
Yeah, I'm not familiar with Eiffel or Bertrand Meyer, but you can basically say like you can build your own data structures, right? But you can also constrain them in certain ways. So you could say, oh, this is a string that has to be 8 characters long, things like that. I don't think you can get super fancy with it, but you can definitely constrain it to, like.
Lengths of things, regex.
I think so. I'm not actually sure.
You can, but we don't like using regex. For transparency, that's not something that we try to implement within services. But yes, we can do. And Evan, I don't know if because you've. Yeah, I know, but from a constraint side, like you guys are able to get whatever you need from our constraints, right?
Yeah, I mean, there's only so much we can do with it. Have it. Getting it to PDL effectively.
Yeah.
We capture.
Yeah, but Smithy also supports things like unions and enums. So you can build like your data model almost like a Scala model and then interpret it.
Sort of at the type level, but you might want to have a constraint where you get this type in, but one of its data members has got to be in some valid range. So I guess you can do the type level too, but I'm just wondering, programming by contract for me, being somebody who did really go up to the value side as well. Not just
Yeah, so the code that's generated from the Smithy will do those checks at runtime. Yeah.
I'm not looking to do.
Yeah. Good.
So SiriusXM is like classically associated with music, media, and binary data. I'm curious like how Smithy would incorporate that, or how your general platform actually interacts with music.
So from the actual music side, so where Smithy shined for us as well is we have our whole catalog content ingestion, and a lot of that is, all right, we take from different feeds of how we now have, because we have live, we have on demand, we have many different like structures. And so that is a very messy world. So being able to, and Sindhu can speak to this at length because her team is the consumer of this catalog data, is how do we now have an actual contract that we now then can enforce that's coming in from all of these different data points. And it's a hard problem to solve, but without Smithy, how horrible would your job been? And even then, like that's a separate team outside of ours, and they did not embrace Smithy to start. And it was more of a when they first started Smithy, it was more of I think how most people think about contract first development. Most people think about contract first development as in I'm going to make a contract. It's a best try towards adhering to this contract, and we're going to make service changes behind the scenes that you're not going to know about, and then you're then going to find divergences to the contract, and then you're then going to come to me to tell me to change it. And that's how it started because of the content side. So it took us a lot of effort to actually get a different group outside of ours to understand the design paradigm shift of no, this is not a after the fact give us a data contract of what this looks like. This is truly a data contract first approach.
Type checking, get back hours or
For checking the schema, basically.
like all this
Yeah.
get like things error or just
So if you give it bad data, it will give you like a general error, basically saying, oh, these are, we've tried to type check your input, and we're having issue with this specific field, and then yeah.
like past that like this, but then I call your service and like I'm in the service.
Domain errors. Yeah, so you can define your own domain errors, and you can throw as many as you want per operation.
Those come back.
Yes, exactly. And so that's what I was talking earlier. Like they basically are wrapped in like throwables, right, in Scala. But you can surface them into like an either, and then pattern match on exactly which case you want to handle. Yeah.
Like you just get back in or
Basically, yeah, exactly. It's just one big, like a union of all the different error cases. Exactly.
And that's and the reason that was big and like we didn't have that solved at first and we had to work through of how to solve that is because the clients need to surface the right error messaging. And so how do you now with Smithy have the correct understanding of surfacing what they need to then have that key to then go look up in their dictionary of what actual messaging they're having to the user, right?
so this is like text build.
I'm not entirely sure.
Yeah, I know Yakub, he's the one on our side that runs API registry. Early on, we definitely had to do a bunch of work around that. I don't know how much you get out of the box for free for that versus how much we had to build internally, but I know for a fact that was a big challenge with the client engineering to start because we were way too willy-nilly in our errors coming back, and we had to get really, again, going to the contract first. We can't just service that. I don't know, Sindhu, if you have more details on.
I mean, we define the error codes and that we return for the client, so these are quite well defined for each type.
But I know that was not something that we had out of the gate, and we had to definitely.
Yeah, I think Jakub and I think the API registry team they contribute a lot of the things that we've built back into Smithy for us. So yeah, and like from a server side perspective, also like if you want to throw an error that you've defined in your Smithy spec, it's as simple as just raising an error inside of AO, and then it automatically gets propagated. Yeah.
You said that this had a lot of services. It allows you if you did, or if you still have
Yeah. So why did we choose Scala as our main? So is the question, why did we choose Scala as our main language for the new platform? Yeah. So looking at the functional programming design, looking at parallelization and concurrency, right? Like Scala is a good language that can handle all of that, like at scale. So for me, that's a major reason. Another main reason is you can get some really good engineers, right, that understand Scala at scale, and that's what we needed, right? So if when I first stepped into this 2.5 years ago, like we needed to find good engineers that knew how to build an AWS at scale to build a new platform. I was able to work to find the Lucas, to get Sindhu, right? Like we got a lot of really good Scala folks. And so that's a main driver. Like, yes, it's type safe. Yes, you got the functional programming design with the with not having side effects and how you can then have the concurrency stuff, right? Like all of that is massive value add, but it's also how we were able to build a platform at scale very rapidly. So for us, it was, all right, it's got to be on the JVM. So it was like Scala or Java. Like, yeah, you could say Kotlin. We're not doing anything with Kotlin. But yeah, we do have Java services, right? So equally so, we do have Java services. Majority of them are Scala, though.
You mentioned, on a slightly different subject, you mentioned like request context forwarding. You have a little bit about that. Is that just like for free getting information about like origination of particular requests as a cast services, or is it flexible in terms of picking out various domain level travels through various service requests?
Yeah, so that's very configurable. So basically, the code generation gives you like a client builder, and from that you can decide like, oh, I want this client to pass along traces, pass along contract request contexts, and then if the server does the same thing, it will keep going until you reach the leaf of the graph, basically, and then come back.
All right, we got one more question.
So it sounds like the Smithy schema is like your one shared repo, and other teams have their own
Exactly.
repos. And so what challenges have you found with sort of making sure that everyone could stay active and productive, and they're all managing these?
Honestly, it's been pretty seamless to me. Like I've only had a conflict in the API registry once, but because usually you don't work on the exact same endpoint definition, right? Like you might change certain behaviors or such, but that's not considered a breaking change in the Smithy world because Smithy doesn't know. But then, yeah, you still have your microservices that you have your smaller teams working on, and then, yeah.
And that's a testament if he's saying that he hasn't had any issues, because, I mean, we're talking about 300 folks in a single API registry. That's the source of truth, right? So, and he's in there continually. So if he's not having any issues, then I guess we got something right.
Definitely, yeah.